Hello everyone, this is Bharat Singla and welcome to CodeChef. Let's discuss the problem shuffling parities from CodeChef September Long challenge with a difficulty of simple and no prerequisites. So you are given an array A of n integers. Chef shuffles it to create a new array B where Bi is given by this formula, that is Ai plus I, that is the element plus its index modulo 2 for each I. Find out the maximum possible sum of integers of B if chef shuffles array A optimally. So after shuffling, he will create a new array B where every Bi is given by Ai plus I, its remainder with 2, right? So clearly, we can say that Bi will always be 0 or 1. At prima facie also we can easily see this, a clear-cut observation, because we are doing something modulo 2. So remainder with 2 will either be 0 or 1. And if this part is even, it would be 0. If this is odd, then it would be a 1. Right. So in a way, find the maximum possible sum of integers can be now converted into find the maximum possible number of ones we can achieve. Because a 0 contributes nothing to the sum and a 1 contributes a 1. Right. So if you have zeros and ones, sum of the array is nothing but the number of ones. And when would the number of ones be maximized? When we have most of the values odd, right? So our aim is to get as many odd values, right? So that odd modulo 2 would give us 1, and then that would have us maximized sum. Okay, so let's quickly have a look at one of the samples. So you have 1, 2, 3. In this case, the optimal way to shuffle this would be 2, 1, 3, because then the resulting array would be 2 plus 1, that is 3 modulo 2. Then you have 1 plus 2, that is 1 plus its index, that is 2 modulo 2. And then 3, the element, plus its index 3 modulo 2. We thus get the array 1, 1, 0. And here you can see that there are two ones. And there's no way to get three ones. So 2 is our answer that we have to report. Okay, so notice that the indexes are defined. So if some part is already fixed, when we want to maximize, minimize, or do whatever with it, if some part is already fixed, then the other part has to be decided accordingly, right? And this is a beautiful problem that really shows that trick. So you have 1, 2, 3 as the indexes, right? As the indices, and it's clear that they are alternating. So there, the first one is 1, that is odd, then 2 is even, then 3 is odd, 4 is even, so on. So this means that 1 plus whatever will be there, right? To get it to be odd, we want this value to be even. Why? Because then 1 plus even would be odd, and then that is what we want, because then that modulo 2 will give us a 1, right? Similarly, in the ideal case, the best possible scenario, with 2 we want to pair up an odd element. So that again the sum of 2 plus the odd element comes out to be odd, and here we have an odd element, right? Then similarly for 3, we want an even element to be paired. So that 3, that is odd plus even, would give us odd again, right? So on for basically for every even index, right? We want to pair it with an odd number, and for every odd index, we want to pair it with an even number, right? So clearly, this basically is a very easy problem. So most of the part is implementation specific. So you can get an idea is that in the ideal scenario, we want to shuffle array to get even, odd, even, odd, even, odd. So based on n, right, we can calculate the ideal number of evens we want to have in the that should be there in V, right, and the ideal number of odds that should be there, right, and then based on how many do we have, right, we can get a formula for that. So if for example there are three even slots, right, so there are three even slots, so we want three evens to be placed, and if for example we have two evens, right, two even numbers, then in that case we'll fill both the slots, right, and then one of the that even slot would be taken by some odd number of the array, right. So in this case we get 2. What if we had three even slots and we had four even numbers, right? In that case, notice that the three even numbers can be placed into those slots, right? And then one of that even number that remains will have to be adjusted to an the odd slot, right? And that is though suboptimal, but that's the best we can achieve, right? So basically, that won't contribute anything to the sum because that even has been paired with another even, right? So that's how you basically get this formula, right? So we can say that This is a kind of a very standard formula that what we want and what we have, right? We can take the minimum because if we want a lot of them but we have only a few, then in that case we'll have to go with the have value, right? Otherwise, if we want very few but we have a lot of them, then we'll get the want one and all the remaining one will be wasted. So if we want five, we have three, right? Then in that case, those three will be evens will be filled up there. But if we have seven instead, right, then two will be extraneous, right? So this way we can do this, apply this formula for even as well as similarly this follows for odd as well. So basically the approach to wrap up is observing that the array B should look something like this and then trying to build as close as this. So there are fixed number of evens that we want, right? That can be counted based on what's the value of n. There are fixed number of odds that we want, right? What's variable is the number of odds that we have and the number of evens that we have in the array that we'll have to check from the array input, right? And after that, ideally we should have placed all of them into their ideal spot, right? But since we may have more or we may have less, we have to take the minimum. And this follows same for both even and odd. So from the implementation, you'll understand this better is that what we can do is first take the input for test cases. Then we have n. This is C++ implementation, and I'll also provide this in the as a pinned comment. So we say that this is line is very clean way to achieve this. That we want even are zero, want odd is zero, have even is zero, have odd is zero. So we iterate on all indexes. Notice that since the problem was one way, so we go on 1 to n. And then we take the input for x, right, for all the elements. We say that if the index is even, then at that place we want an odd, right? With an even index, we want to pair an odd. So in that case, we increment the wants of odd. Otherwise, we increment the wants of even, right? We want another even here if this is odd. Similarly, if x is even, then the number of evens we have, we are incrementing, and otherwise the number of odds. So this basically just they basically store the number of odds and evens, and they basically store the number of what we desire. Finally, we can count the answer by taking the minimum of how many evens we want, whereas how many we have. Right, others will just remain and won't contribute anything because they have to forcibly be paired with some odd number, right? Similarly, for we have for the number of odds we want, whereas the number of odds we have. Take the minimum. This is a very well-known trick, right? And then we simply output the answer. Let's quickly run it though. So we get 2, 3, 1, which I guess matches. So let's quickly submit this code. So here I have it already pasted. Let's quickly hit the submit button and let's get it evaluated by the online judge. And yeah, you can always ask any of your doubts in the comment section. If you like the explanation, make sure to hit the like button and share it with all your friends whom you think may find it useful. So let's see the output. Okay, so we do get an AC. And yeah, this wraps up the video, guys. This is Bharat Singla from CodeChef signing off for now, and I will see you next time.